Okay. So, just getting that camera. So, 5.1, we're trying to deal with probability and the fundamental principle of counting. So I've got 6 books, and I've got to arrange them. Obviously 6 places, that's the 6 boxes. So, first place, I can put 6 books. I'm left with 5, 4, 3, 2, 1. And that's the same as 6 factorial, multiplied out, it's 720. But what if with these books, I said 2 books have to go together at the front? Okay? So we're arranging 2 of the books, and you've got Andrew Agassi's autobiography, which I recommend reading, excellent, and Culture Code. Both of those great books have to go to the front. Okay? So now they're together. And now I've got only 5 boxes. Yeah, because they have to go together. So I've got 5 options here. Or sorry, this has to go at the front. So how many options do I have for first place? 1. Yeah. How many options do I have here now? Well, I've got 4, because 2 books are used up. There's only 4 left. 3, 2, 1. Now, here's the thing. In this 1 here, I can go Andrew Agassi, Culture Code, or I can go Culture Code and Andrew Agassi. So you always put in here 2, the amount of books that is, well, sorry, now you scratch that. You got 2 factorial. If it's 3 books, you do 3 factorial. What's factorial? 6 factorial, 6 by 5 by 4 by 3 by 2 by 1. Okay, so 2 factorial is 2 by 1, which is the same as 2. 2 by 4 by 3 by 2, well that's 12, 24, 48. There's 48 ways. Now, if I was going to say a little bit harder, I was to say the books here, I want to keep those 2 books still together. But that's the only condition. They've got to be together. That's the only condition whatsoever on it. So once again, you're going, well, that's 2 factorial. Okay? Now, because the books can go Culture Code or Andrew Agassi, Culture Code. That's 2 ways to arrange it. Now, this can go absolutely anywhere. So, I'm multiplying. You've got 5 spaces. This can go, you've got 5 options for first place. Yeah? Because this is taken as 1 book now, the 2 together. And then there's 4 others. Now there's 4 here. Just 3, 2, 1. So that would be 2 factorial multiplied by 5 factorial. 5 factorial, 5 by 4, 20, 60. Well, 5 by 4, sorry, 20, 60, 120, 240 is your answer. Okay, I got a code for my phone. Got 2 options. Which is safer? 4-digit code where numbers can repeat, or we can go a letter, number. Okay, where you can repeat 10 digits in the phone. Yeah, 0 to 9. Count it up. 0 is 1, and then 1 to 9 is 9, so it's 10. 10 by 10 by 10 by 10. If you couldn't repeat, it'd be 10 by 9 by 8 by 7. This would be 1, 0, 0, 0, 0. 10,000 options. Now, letter. 26 letters. If the letters can't repeat, or let's say they can repeat, it's 26. If they can't repeat, it'd be 25, and that's by 10. 26 by 26. Let me see. I'm curious now to see which one's safer. I'd probably go to the letter. But I could be wrong. I've been wrong many times before. Actually, I'm wrong in this one. 26 multiplied by 26 multiplied by 10. Oh, I messed that up. 26 multiplied by 26 multiplied by 10. That is 6,760. So this is more secure. Why? Because there's 10,000 possible codes. There's 6,760 here. Yep. A woman, very sad woman's got 10 ornaments. And she wants to arrange them in 7 different ways. 1, 2, 3, 4, 5, 6, 7. She's got 7 spaces. Well, she's got 10 here. 9, 8, 7, 6, 5, 4. Yep, that's that done. Now, if, hypothetically, I said that she knows that she's going to put 2 in the beginning and 2 at the end, and she doesn't know what other ones are going in here. So that's 2, 4, and that's that there. So she knows 2 are going in the beginning. That's 2 factorial, 2 A's, and 2 A's at the end. Now, I've used up 2 here, I've used up 2 here. That leaves us with 6 by 5 by 4, and put that into your calculator. Remember, 2 ornaments at the beginning, but I could go ornament A, ornament B, ornament B, ornament A. And same again, C and D, or D and C. The reason why this is 6, but this has to go at the beginning, so that's why there's no flexibility here. Now, and then 6 is, well, this is the most important one, these 2, because conditions are put there. If I was to say to you, these 2 have to be together, these 2 have to be together. Right? Well, we know that's 2 factorial. We know that that's 2 factorial. How many boxes? 1, 2, 3, 4, 5. So that would go 5 by 4 by 3 by 2 by 1. And that's going to be 4, 20, 80, 240, 480. There's your answer. Okay, what I'm going to give you, your work is for Monday and Tuesday. I want you to do all of exercise 5.1. That doesn't mean leaving it to the last day, okay? If I said to you, actually, one last one. If I said to you that these 2, or if I'm doing the very first one here, back up here, okay, there was 6 books, and this one said that the books had to be together. Okay, what if I said to you that the books could not be together in first place? Yeah, well, that answer would just be 720 minus the fact that they have to be together in the first place. Yeah, so if you just said they cannot be together in first place, or they cannot be together, get the chances of them together and then take it away from the total possibilities. So I'll actually do an example for that. We're saying that 2 books have to be together. Yeah, there's 10 books and we've got 3 places to fill. Or we've got 4 places. 2 books have to be together. Okay, so that's 2. This leaves us with 8. Yeah, so we've got 9 options here. Because this is an option. We're 8 left here. So by 8 by 7 equals. That's with them together. This is no limitations. 3 spaces, 10 by 9 by 8. This is to say they have to be together. This is to say any order. If I'm saying that they have to be together, they have to not be together. Yeah, you would go this minus this, and that will give you the answer. That might be confusing at the moment, but it won't be in the long term. Trust me. Okay, don't forget your homework. You're doing all the questions on 5.1. So, half of them Monday, half of them Tuesday.